Okay. Hi everyone. Let me welcome you to the last session of this day. It's always a hard task to kind of focus and attention after lunch, but I hope that we'll be able to manage this somehow, because we have a range of super interesting presentations right now. But before we move to this point, there's a practical announcement. So I hear.
So just a really quick reminder, if you haven't given me your video and photo consent form, please sign it and give it to me. And if you have your expenses declaration, you can also give them to me, but that can be fixed later. But the video and photo consent form, please, that I need.
Okay, great. So we're moving, probably by my count, to the most exciting part of this day. Not only because I'm chairing it, but also because it's a paper session. And European University Institute prides itself in including younger researchers in almost anything we do here. So I'm happy to say that we have such a session here. We have 5 fantastic papers that were selected in a competitive process out of many submissions, and they cover a very wide range of issues. So bear with us while we guide you through all of them. First, we will have a presentation about EU policy frameworks for AI by Inga Unikane-Ozolina from De Montfort University, where Inga works on the Human Brain Project. Then we will follow with 2 presentations on ethical safeguards. One on standard setting by Gianpiero Negri from University degli Studi di Salerno. Gianpiero is also a project safety manager in various CNH programs, and maybe you can tell us a little bit what that means. And then we will follow with another presentation on ethical safeguards by Nikita Agara from the Faculty of Law, University of Oxford, and we are hoping to hear about the Confucian perspective on ethics.
Just to clarify, I'm not speaking about ethical safeguards.
Well, so it was in yours. It was. I think that was in your abstract. But okay. Then the surprise presentation. Apologies. Then we are moving to a presentation about liability in healthcare, and I hope that I don't misunderstand this topic by Francesca La Gioia from European University Institute, and Giuseppe Contisa from University di Bologna, only to end up with, last but not least, Leonard von Rompuy from University of Copenhagen from the Faculty of Law, and his presentation will be on algorithmic translations and what does it mean for us and for the world. So without further ado, let's start with Inga and her presentation.
So thank you very much, and I will talk about global politics of artificial intelligence and institutional context within which this research is taking place. As you kindly mentioned, is the Human Brain Project, which is a large-scale European Union-funded project, bringing together more than 800 researchers, neuroscientists, computing scientists, engineers, and also social scientists. It also has a big society and ethics part, and I am working on that. And recently, also, the Human Brain Project has got very much interested in artificial intelligence. And within society and ethics part, we also look on political, social, and ethical aspects of artificial intelligence. So why focus on politics of artificial intelligence? Why it is an interesting question? And here you can see this map might give some idea. So what is happening very recently in past year, we see that there's a lot of political activity around artificial intelligence. Many countries around the world, also many international organizations, are developing their artificial intelligence strategies, action plans, all kinds of policy documents. And it's happening at a very high speed, and this map is also showing this very high speed. This map was published published in a couple of months ago in early 2018, showing a number of artificial intelligence strategies adopted by several countries, also several developing them. Interestingly enough, just a couple of months later, this map is already outdated, because since then we have had like a new artificial intelligence strategy published almost every week. We had the French Macron strategy late March, then in April we had UK House of Lords, we had the European Union. So there's a lot of political activity. And one question, of course, is why politicians are so interested in this artificial intelligence developments. If you look what are statements, what political leaders are saying, we can see kind of new global race emerging. Many countries, many political leaders are announcing that they are very much interested to be leaders in artificial intelligence development. So we had the United States, who is one of the leading countries at the moment, probably the leading by many metrics on artificial intelligence. Then there are very fast developing changes taking place in China. There are also France and UK have announced that they want to be leaders in artificial intelligence, and recently also European Union, what we heard also yesterday, said that also European Union wants to be a leader in its own way, according to its own values, and kind of saying that European Union's secret weapon in this global race for AI would be ethics and ethical standards. So we have seen similar technological races already quite a lot. If we look back already to 60s, to 70s, one of the most famous was space race. There was also other AT race and many other technological races. And there are certain positive developments related to such technological races, but there are also certain problematic aspects. So among positive, one can say there are a lot of attentions, there are mobilization of resources, there are fast technological developments, which can also benefit a lot of large part of society. But there are also a number of more problematic aspects, and we can mention at least two such problematic aspects. And one problematic aspect is that such technological races very often say that these technological developments are kind of zero-sum game. Namely, one country gains, another country loses. And that means that there's only one winner, another are losers. And that zero-sum game understanding of technological race can also be questioned because technological development is not necessarily a zero-sum game. It can be also a positive-sum game when overall benefits of technology increases and there's larger pies that can be distributed and everyone can develop. So that is one criticism. Another criticism, what we see about such a competition among countries is what we already saw in 1990s when Paul Krugman said that such technological races, they can, he called them that competitiveness is a dangerous obsession because it might channel all the resources into certain technologies while like overlooking others. And that can also go already back to the debates that were present in 1970s, like from Nelson, the moon and the ghetto, that there are very fast development in certain technologies, like space race going to the moon, while there are much more problematic areas, such as, for example, solving the problems of ghetto. And that is interesting to think about in the terms of this global competition, because there has been like global competition in terms who will be the first going to the moon. There has never been a global competition, global race, who will be the first to solve the problems of the ghetto. And that is also interesting in terms of AI developments, because who will benefit from AI developments, and also how policies will be framed either to increase like more distribution or allowing kind of increase of existing inequalities. So there's a lot of competition. There's also cooperation, saying that these new developments also need new alliances. And there's also kind of hybrid development, combining competition and collaboration. What we know already from science studies, there is this hybrid notion coming from Merton of competitive cooperation. So scientists, technology developers, they are always competing, and they are always also collaborating at the same time. And we see this also in the European Union, like a month ago, European Union countries, also 25 European countries signed this declaration to collaborate on artificial intelligence. And these were 24 countries plus Norway. And there were a couple of interesting moments in signing this declaration for collaboration. One was that when French representative was asked how France will collaborate with others, he said that France actually want to lead. And this is, again, this interesting hybrid of competitive cooperation. So we want to lead or we want to collaborate. And another interesting thing is that from European Union, these were 24 countries signing, and not all 28. So, and 4 were absent of signing. And that's an interesting question. If 4 countries are not present at the very beginning, is it a kind of new divide emerging? And if EU's kind of policy statement is that no one is left behind in this new transformative technologies, then that could also be a matter of concern. So, how EU is understanding artificial intelligence. So there's some of policy framings. And basically what you can see here is that there are very high expectations that this will be transformative technologies, this will be steam engine of the 21st century. And at the same time, there is also this kind of ambivalent situation, what we see in EU and what we see in many other documents, that on the one hand, countries and also European Union wants to facilitate development of artificial intelligence, but on the other hand, also make sure that those who lose jobs can be retrained, and that also like all kinds of social and economic concerns are addressed. So this is kind of broader policy and intellectual context for our ongoing research. So what do we do exactly in our research? We are building a database of policy documents on artificial intelligence from countries around Europe, from North America. And it is from national governments, it's also from international organizations, civil societies, and business consultancies. And on the basis from political science and also from science and technology studies and innovation studies literature, there are a number of research questions to be addressed. It is about framing of artificial intelligence. It is about positive and negative expectations. It's also about differences, how different countries, how different policy actors like civil society versus business approach artificial intelligence, and it is also about recommendations which are set out. And if you look on differences, then some typical differences that one can see in these documents is either major focus kind of on economic benefits or also like looking on more ethical and responsible artificial intelligence. And so one question about artificial intelligence, if we look in this long-term development of new technologies, is always how much new is there on how much there are things we have seen with previous technologies. And we see that there's a lot of, like, if you look on science, there's a lot of things that we know very well from previous technologies, that there's a lot of competitions, that there is a lot of also rivalries, that there's a lot of scientists, technologists attracted to this field. One difference that we can see also from previous technologies that there is not only science, but for this particular technology, also private sector is very much into the driving seat. And here are some of the frameworks that we are using for analysis. So it is about policy frames. So it's how facts, values, theories, and interests are intertwined in these policy formulations of artificial intelligence. And then we draw also on innovation studies and science and technology studies literature on emerging technologies that looks on hypes. And here hypes are defines that they are not looking on hypes as a forecast, but more as a collectively pursued explorations of the futures that affect activities in the present. So it's not this common kind of skeptical idea of hypes, but really looking how hypes work and how they influence development of technology. And then also on positive and negative expectations, how such expectations provide legitimacy for certain actions, and also influence mobilization and allocation of resources. And so my final slide. With this research, we have three main aims. So scientifically contribute to this studies of emerging technologies and put artificial intelligence with this longer term perspective of emerging technologies, then also contribute to discussions about specifically artificial intelligence. And finally, as institutional context, also to shape artificial intelligence research within the Human Brain Project. Thank you very much.
Fantastic. Thank you so much, Inga. I'm wondering whether we should do short debates after each presentation or rather try to cluster all the presentations and then do the debate. What do you think would be a better?
Maybe just a couple of questions.
Yeah.
I think
after each. So that's fresh. Okay, great, great. Fantastic. Maybe I'll start with just one question. It's really fascinating to see that someone's doing this kind of groundwork with building a database of policy documents. And my question is whether this will be an open access resource for all the other researchers to use, or whether that's not the case. And let's open the floor for questions, other questions to Inga. Yes, please.
Thank you. I'm just curious, since you're working in the Human Brain Project, how considerations from cognitive sciences and your colleagues' work enter in your line of research on this project. Thank you.
Thank you so much. I wanted to ask, is it the character of the project you're having, is it purely, say, descriptive mapping of what is going on so that we know what is going on, or is there some critical flavor to it in a sense of assessing whether what they're talking about is actually what is going on, or whether it's just some political ideas? And if yes, could you give us an example or two of what you think is really the most far-fetched in the heaven science fiction-based policy you've seen till now?
So
there's one question at the back, and then we can start.
Mayor? So I wanted to ask about the European logic for the project, and how you see the place of the resolution the European Parliament took in February 2017 on civil law and robotics, and to what extent it could provide for a frame. So we saw that in the communication of the Commission. The communication actually refers to the call that was made by European Council, not that much to that document of the Parliament. And then we have the joint declaration that, again, is more on intergovernmental level. So do you see that in your project you could have it more aligned with this European logic of having first a resolution, then communication from the Commission, and then legislative acts following that?
thank you very much. I will give very brief answers, and if there's then follow-up questions, we can discuss it afterwards. So about if this database would be open source, it would be very good to have it, to make it open source when we have put a cutoff line, because at the moment there are still a lot of documents coming out. Then about cognitive scientists and how they enter social science research. That is a very key question for Human Brain Project, but also for many other projects where social scientists and like natural scientists, engineers work together. And it is indeed always a conversation, and conversation that is going both directions, that research that is done by natural scientists informs what social scientists are doing, and also what social scientists are doing. Aim is also to influence natural scientists, to facilitate their reflection, to facilitate responsible research and innovation from their side. Then next question about descriptive or critical. I would say because it's theory informed, it is looking on policy frames, it's looking on also things like how different values enters into politics and what kind of influence they have and what kind of this influence these hypes have. So the aim here would be also to see how this policy perception, how they influence policy actions, which then have also impact on science. So it would be analytical work, also reflective work on impact of policies on, and how also policies emerge and how they then influence science. And final question about European logic. There is, of course, this policy process which we can look on as well, but our main aim at this point is to look on policy content. Where this policy content comes from? Is there major differences in policy content that comes out of Parliament and that comes out of European Commission, that comes from different nation states and also different stakeholders, and there are differences, and the aim is really to understand these differences in policy content.
Okay, great. Let's move to Gian-Piero now.
First of all, thank you for inviting me. And I will start with this presentation related to the topic, which is describing some of the most critical challenges and approaches. Thank you. Some of the critical challenges and approaches in ethical machine development. And I will try to introduce shortly myself, first of all. Then I will try to describe a sort of statement of problem. And then we will describe some possible approaches, and more than provide some answers, I will provide some questions, some good questions in this side. So, and finally, I will add another fourth issue, which is related to the so-called problem of misdirection avoidance, and then we can go in details, and then provide some further references on those on this work. First of all, my background is in engineering. I graduated in electronic engineering at Salerno University. Then I became a researcher at Italian National Research Council in the field of mechatronics. And currently, I am a project safety manager in Senici Industrial, which is an industrial company which is born from the merging of the industrial activities from the Fiat Group. And basically, it works on industrial machines, several types of industrial machines. And besides, I also am a member of a technical committee, more specifically a work group, which is working on autonomous machine safety in the ISO organization. ISO stands for International Organization for Standardization, and we are working on the release of the amendments of a new standard, which is related to the autonomous safety, autonomous machine safety. I also cooperate with IEEE as a scientific reviewer. Just to have a look to what CNH Industrial is, it is an industrial company with, it is very large, 70,000 people, more or less, and it manufactures, produces several types of vehicles. As you can see, we have construction equipment, agricultural equipment with a very, very complex architecture, truck, bus, and recently we moved to a very interesting topic, which is the development of autonomous machines. And as you can see in the middle of this slide, there is an autonomous tractor that is a concept in this time, but we are struggling on that. We are working on that with this activity. And for what concerning the PhD, I would report the main topics I'm working on, which relates with this topic strictly, which are basically the possibility to apply the game theory as a mathematical approach to autonomous dynamical system, and to apply some kind of specific logic in the development of the algorithm of the machine, which is deontic logic or something different. And finally, topics is the mathematical modeling of a decision system for autonomous vehicles, which is, let's say, a very critical topic in the sense that we should provide a machine with an autonomous capability to operate in the environment. And so, what is the problem? The problem is that there are a certain number of risks in take those kind of vehicles moving on the field. For whatever machine, the first risk is related to the safety, in my opinion. The safety of the human beings in the sense that when we all have vehicles and machines to operate as themselves, they can produce some harm to the people, basically. And what is the current approach which is used in the industry? The industry uses mainly ISO approach, an ISO approach which is based on ISO standards, and there are a lot of ISO standards. For example, there is a generic ISO standard which is related to the industrial machines, which is the IEC 61508, and it is a sort of mother standard, and it has a certain number of SANs, and those standards are applicable to different domains, for example, automotive domain, or construction equipment, or agricultural equipment, or even collaborative robots, since there is a specific ISO standard to ensure the safety for collaborative robots, which is maybe has been described yesterday, I don't remember, but I think so. Okay, and for what concerning strictly automotive, which is a domain which, let's say, there are a lot of discussion in the literature and also in the mass media and so on. We have normally a single standard to be adopted in order to ensure the safety in the development of the machine, which is the ISO 26262, so-called, which provides a very, very detailed process in order to define all the technical requirements to be used in order to ensure a safe behavior of the vehicle. And for sure, this kind of standard must be applied also to the autonomous side. Even though, as per today, there is not a specific standard for autonomous cars. There is something which is similar to an extension of the ISO 26262 to the cars, but I will say that this must be covered. This is not covered exactly. For what concerning other kind of vehicles, for example, for construction equipment, as I said before, there is a specific standard which has been also already released. But let's go to another possible approach, which is different to the ISO standard, with respect to the ISO standard. This is the possibility to introduce the ethics directly in the machine. What is this concept? This concept consists in, for sure, incorporating algorithms in the machine. Those algorithms are based on the most general AI techniques you can imagine, but they are also implemented and tested in such a way to make sure that the machine, as general being, can have a safe behavior with respect to the people. So I would introduce three main issues in doing that. Those three issues are, the first one is, let's say, an identification of what must be the machine ethics principle to be adopted, since we don't know. Basically, today, as per today, we don't know what are exactly the principles to be used in order to ensure that the machine have an ethics or a safe behavior. Then I would face a second issue, which is how we can incorporate, how we can have embedded in the machine these ethics. And last one is how can we define the interaction degree between the human beings and the machines. For the first one, I would refer, first of all, this is a philosophical problem, a philosophical issue if you want. We have to define some ethical principle, and for example, we can refer to some classic ethics principle, and I think that most of them are listed in this slide. For example, the first one is the so-called the non-maleficence principle, which is basically something similar to avoid the hazards for the human beings, something like that. There are also other principles, for example, the beneficence principle, which is act in ways that promote the welfare of other people, which is not strictly included, for example, in any safety standard, which relates mainly on the first one. And just to provide an example, this is from science fiction for sure, but it is something which must be translated in the industry today by means of ISO standard, for example. And speaking about the Asimov laws, which are related to the fact that a machine must be designed in such a way to avoid producing harm to the people. But there are also some most recent translation of those Asimov laws, for example, provided by Google, which are more or less always focused on the safety of the people. And as last example, we could consider the report which has been issued by the Ethics Commission of the German Agency for the Transportation, which lists a set of possible requirements to be satisfied in order to manufacture and ensure that vehicles, mainly cars, act in a safe way when put on the road. Okay, coming to the second problem. What is the second problem? We should try to incorporate those kind of principles once identified in a machine, so that in the decision system of the machine or the robot or even the vehicle those principles must be incorporated. How we can do that? We can consider some references. A first reference could be, for example, the game theory, which is the study of mathematical models of conflict of operation between intelligent, rational decision makers, which means that if we develop a strategy in the decision system of the robot, which is based on this game theory, we could ensure that considering a fleet of machines, they act in such a way to avoid producing harm to the people. And based on this algorithm, okay, we can try to find a best solution, which is most probably something like a Nash equilibrium. I don't want to go in details, but those are all mathematical concepts, which can ensure that the overall benefit is maximized. We can use also some other approach, which is the use of a specific kind of logic, which is a sort of translation of the deontic principle in the algorithms. Okay, something which can be translated in some algorithms and include in itself, let's say, the concept of obligation or permission. Okay, and this kind of approach can be used, for example, to code something and to put this code inside the machine. In such a way, the machine can act according to these principles once identified. And as a third problem, we have to define what will be the degree of interaction between the human and the machine. For example, in the medium level of interaction, in which the machine can be, for example, programmed, let's say, one shot, and then something can be provided in order to, I would say, tune its ethical behavior. And this is the work from Francesca and Giuseppe, which are here, so they can explain better than me. But we have some, let's say, boundaries in this kind of interaction, which are, let's say, basically the low and the high degree. And when we have a high degree of interaction, basically the machine is not autonomous. And when we have a low level of degree, basically we want the machine as its behavior by itself, basically, with a minimum level of interaction with the humans. And what is the really hot and critical issue in doing that? The machine can be misdirected. All the machine can be misdirected, which means that even if we design and test and put every possible ethical and safety principle inside the machine could be modified, changed, and used in a different way with respect to its scope. And this is a very hot problem. And here I will just to highlight and propose something which is based on the so-called neuromorphic engineering. Just to conclude and provide an example. I'm thinking about something which is happened, for example, in the medical environment, in the hospitals, where a worm, which is called WannaCry, last year produces a lot of damages and blocking several machines in most part of northern countries, I guess UK and USA as well, mostly in UK. And okay, the problem is that the medical system, let's say the overall system was very, very sophisticated. There are a lot of computers interconnected in network. And my focus is, but if, for example, we have a lower level of progress inside our organization, so if we don't use computers, for example, it will be possible to have an hack. It will be not possible. And this is exactly the concept on neuromorphic engineering. We don't produce software, but we produce components with, let's say, a behavior inside, which is not software. So that okay, just to conclude, so that we can hard code inside a machine in a very efficient way some ethical principle which cannot be hacked, basically. And that's the last concept. Then there are some references, and I will thank you for the kind attention.
Let's just open the floor for questions. There you go, Przemek.
Yeah, thank you very much. It's I think the field of machine ethics is really crowded, but it's always great to see that someone who's an actual engineer and knows what's happening inside is doing that. So that's great. My question to you would be, in a sense that from what you presented, that you clearly do distinguish the normative question. So what is it that, apart from, say, the engineering task that we want machine to do, say, an automatic tractor to do well, whatever tractors do, should be there as, say, ethical or whatever normative, whether it comes from philosophy or what comes from law principle, that it sort of realizes part of the task. And then there is this part of how to do that. On how to do that, I don't know, and I'm really happy you're doing it, because I think that's what we're missing in the normative sciences. But my question to you would be, on what level of generality you want to remain? Because you're talking generally about roboethics, and you used that example of a tractor, then you're talking about Asimov. But then, as many people have already indicated, we're really far from, say, general AI, no? So these machines are all realized for particular tasks. And then the bad things that the tractor can do are very different from the bad things that high-frequency algorithm can do, and are very different from what, say, Facebook newsfeed can do. And so do you think there is a chance to come up with, say, a general solution to it, and is that what you're looking for, or do you have some case studies and you just want to stick to that?
Okay, this is a very good question. Actually, there is no common approach in that, in the sense that, for example, remaining to the ISO standard, as I said before, we have a lot of standard which is applicable to different machines, which means that even if we use a traditional approach, we cannot use the same standard for all the machines. And okay, I guess that the most proper approach is to proceed with an incremental way. First of all, I would have, and we are working in order to do that, to propose some, let's say, cross-domain standard for safety. This could be a good first step. Okay, so taking inspiration from IEC 61508 to produce something like a general autonomous machine safety standard. And currently, we have a single working group in all the ISO organization which is working on that, which is my group, basically. And our work is focused on producing something which can be used in general. And for what concerning the ethics, it is a pretty different problem, since safety is just a part. And I will say that, for what concerning a company, it is not a very hot topic so far, but it can become in the future. So I think that even on this point, it will be a lot of work required in next years.
Okay, great. We have a question here.
Matt, for this very interesting presentation, and I myself have been dealing with this kind of issue, so I'm very happy to see that you are taking up. Maybe also Przemek addressed and mentioned that, so you are using very broad principles. I think that was Aquinas who said that the principle of ethics are do the good and don't do the bad. Bonum faciendum malum vitandum, something like that. So how a machine is going, so it supposes that a machine is able to know what is good and what is bad, what is harmful, what is not, and then to select the ways in which to achieve that and not to achieve the other, avoid side effects, etc., etc. So do you think that it is reasonable to expect that a machine will be able to do that? And secondly, my second question concerns implementation. So you mentioned putting these ethical principles into hardware. Can you, what kind of hardware do you have in mind? A set of rules, a neural network, trained, whatever?
Okay. For what concerning the first question, let's say actually it is a very broad, there is a very broad range of possibilities. So I will say that proceeding in an incremental way, we should first of all select some applicable scenarios. From what concerning our side, so CNH Industrial, plus my research in the PhD, let's say we will focus on some specific application in industrial machinery, which okay, can act in a constrained environment, so that it is, let's say, a problem completely different with respect to the one we have in the cars. But we hope to find in this constrained scenario and environment some useful solution, and those principles, in such a way, those principles could be extended to other scenarios in an incremental way. And that's the first part of my answer. For the second part for the second question, okay, I proposed a way which is, okay, there are two parts in this answer. The first part is the hardware, and the second part is the software. For concerning the algorithmic strategy, we can use pretty everything. We can use, for example, the machine learning, which is a good example. We can use the game theory, which is a mathematical theory which can be implemented directly in software. But we have to select the hardware in order to put this software in place. Currently, the issue is that the software and the hardware are separated beings, I will say, separated entity, I will say. And this is exposed to be hacked. Okay, this is something which can be hacked, since on the same hardware I can modify the software. And the software can be modified using the same channels which are used, for example, to tune the software itself or to upload the software itself. And this is an issue, in my opinion. So our proposal would be to move in the future to another paradigm in which the logic is hard-coded, basically. In such a way, we can avoid that the program can be changed. So the core part of the machine could be hard-coded this way. Then we can have also other layers of the architecture which are not related with the ethics or with the safety, which can be implemented in traditional way. But the very nuclear part, which refers to the safety and to the ethics, should be implemented in a very different way with respect to the current paradigms. That's our opinion.
Okay, and just as a follow-up to this, I liked the part where you talked about the ISO standards, but I'm wondering how, if I understand correctly, ISO standards, they happen in a kind of industry-constrained silos. So I'm wondering, how do you want to go about dual-use technologies? And then the other question about ethical principles and embedding them in the machinery, how would you want to cater to the divergence of ethical stances and kind of cultural diversity, etc., etc.?
Yes, this is okay. Starting for the last question, okay, I think this is a matter of philosophical research. Okay, it is not a matter of technical or scientific research. So what I want to highlight today is that we cannot perform this kind of research in the engineering side. We should, let's say, highlight that this kind of problem is present, since we are developing machines which can act autonomously. So we have to push in order to obtain from other domains those answers, which must not come directly from our department, since it is not possible to answer those questions by using just technological or scientific means. That's my guess. Coming to your first question, the first
on the ISO standards and dual-use technology.
The differences between the ISO standard, you mean, or what more, to be more precise? Yeah.
No, so if I understand ISO standards correctly, they developed in a kind of industry-constrained silos. So then, how do you go about regulating, and standards are a part of kind of regulatory environments, how do you go about regulating something that is essentially dual-use? Mm-hmm. Right? So
yes, basically ISO standards are applicable to industrial machine. They are applicable to specific scenarios, But every and each ISO standard is applicable to a different machine, and for example, just to provide an example, on construction equipment, the ISO standard is mandatory since it is harmonized to the machine directive, which means that if we develop and test a machine according to the ISO standard, the machine can be put on the market, otherwise it cannot. So right now, the ISO standard are used just with this aim, in order to provide the requirement which must be used in order to develop a safe machine.
But the bottom line is that it doesn't really prevent malicious use of the same, let's say, algorithm in the other context.
That's correct. That's correct, but for example, there is a section, there are specific standards of cybersecurity, for example, but there are specific sections on cybersecurity applied to machine, for example, in ISO 17757, which is the one on which I'm working on. So that even on that, I think that it is needed a convergence between different domains in such a way to define, if possible, an harmonized way to manage the cybersecurity issues. And not in order to avoid they could become, let's say, domain specific.
Great, thank you. If we don't have more questions for now, let me hand over to Nikita.
Okay, thank you, Maciej. So I'm going to talk about machine learning and big data in consumer credit markets, which I've labeled all data as credit data, and it's a quote that is attributed to Doug Merrill, who's ex-Google and CEO of Zest Finance, which is a US platform, but now sells basically machine learning technology for credit scoring. So an overview. The paper proceeds in three parts. First, a technological analysis. Secondly, a market analysis. And thirdly, a regulatory analysis. And in the next 10 minutes or so, I want to present an outline of each of those three parts. First, the technology. So what I'm looking at is the use of machine learning and big data techniques for credit scoring specifically and more generally in consumer credit markets. The market analysis is looking at what are the implications of this from a market perspective, and that's sort of a fundamentally economic perspective. And I'm taking two main measures. One is the implications for market efficiency, and the second for distributional fairness. And then the third part is to assess what the existing regulatory framework looks like for consumer credit scoring and consumer markets more generally, and how they can respond to these effects. And for this, I define regulation more narrowly as laws adopted and backed by government action. But of course, law in that regulation in that sense can regulate markets as well in a kind of broader sense. Okay, so let's begin by talking about the technological development. First of all, what is credit scoring? So this is, put simply, the use of statistical models to predict and estimate a applicant borrower's potential credit risk. It's also broader than that. So in the UK, at least, credit checking is more than just credit risk. It's also affordability assessment. So we start to talk about credit worthiness. And any country that has sort of fair or responsible lending laws will build in this element of affordability. Traditional credit scoring models rely on basically quite sort of explicit programmed approaches, linear regression, static, limited categories of information. The most important would typically be credit history, which is the history of financial payments. And they're used to build a scorecard where you sort of have a range, and borrowers are put into different buckets, essentially, according to their perceived risk. And the credit is priced accordingly, and there'll be a cutoff mark or a pass mark below which a particular lender may choose not to lend at all to that particular borrower. So what is smart credit scoring, as I've chosen to call it? There are two dimensions. The first is looking at new types of data, and the second is new types of modeling, and the second influences the first, the types of data that can be used. So let's look at each of these dimensions. the alternative data, so there's two parts. One is using non-financial credit data. So rather than just bank payments, we're talking about rental payments, maybe your Netflix payment history, payments that many people have made, and it could speak to a person's ability to manage money, but not necessarily through a bank account. And as you can imagine, this has quite significant implications for countries where large parts of the population are unbanked. Then the second type of alternative data is actually not credit data at all, and this is back to the aphorism that all data is credit data. And here we're talking about a much larger spectrum, so behavioral data, social data, whether it's your online browsing history, your search queries, etc. And it's not just relating to that individual, which is quite an important point. It's not where you have how you have paid, but also demographic data that could talk about how people like you behave. The second dimension is the sort of type of modeling that is used, and here we're talking about moving from linear regression and sort of static categories of data and explicit programming to using machine learning and more advanced modeling techniques. The main benefit of this is that you could potentially find nonlinearities in the data, and it essentially expands the categories of data that can be used. You can use unstructured, high-dimensional data that wouldn't have been possible under a more static approach under traditional credit scoring. So that's the technological phenomenon. What does this mean for credit markets? My paper essentially argues that the effects of smart credit scoring in consumer credit markets will be driven primarily by changes in information dynamics. And by that I mean asymmetries between market actors and regulators, and also heterogeneity of information between market actors. And they're slightly different things. So the changes in information, and by information we mean not just the possession or access to information, but also information processing capacity, which is a key element when we talk about asymmetry of information. So I have here tried to somehow visualize what information looks like in consumer credit markets. And the main takeaway from this, and the main point to emphasize here, is that the flow of information is bidirectional and multi-directional. But one party will typically have more and better informational capacity than the other. And I'll draw your attention to the relationship between lenders and borrowers, where you have both lender ignorance and borrower ignorance. In the center, you have the credit reference agencies, credit bureaus, if you like, who take information from creditors, from lenders, aggregated and also presented in the form of consumer credit reports. And then, of course, the regulators, who also have an informational relationship with the entities that they are regulating. And so what does smart credit scoring mean for these relationships? So I suggest a few shifts in information dynamics in consumer credit markets. The first relates to the relationship between the firm and the consumer. And here we can see two things changing. The first is that the firm or the lender is, on one hand, at a disadvantage in that they can't really predict with precision how a borrower will use the money. So this is a creditor ignorance. And the effect of smart credit scoring is to reduce that asymmetry, to reduce that ignorance by allowing more observable features. And that has an efficiency gain and potentially a distributional benefit, where you increase access to credit to previously marginalized communities, people who had very thin credit records, thin files. And also this could have potentially beneficial distributional effects, where those communities are predominantly low income, lesser educated, and of ethnic minority. On the other hand, you also have a consumer ignorance. So a lender knows much more about the credit product than the consumer typically would, based on their experience with that product over time and with multiple borrowers. And the credit markets sort of lend themselves to asymmetry of information because of the nature of the product. You don't know the quality you're purchasing even on purchase. It's only over time, and even then you may not know whether you got a good product. So in that respect, there's a risk that smart credit scoring could exacerbate the lender's advantage by giving them much more insight into the behavior of the borrower. and their activities. And this has a potentially positive and negative effect. The positive effect could be more personalized, more efficient contracts, better tailored to the characteristics of that particular borrower. On the other hand, and this is the scenario that we would typically be more concerned about and consumer protection law responds to in many ways, is the risk of manipulating borrowers based on those vulnerabilities and personal characteristics. If you know more about their vulnerabilities, it might follow that you have a greater ability to manipulate. Somehow plugged onto that same dynamic, though, there is a scope for AI, so machine learning, big data, in the hands of the consumer to potentially dissipate or to reduce that informational advantage of the creditor. And if we think of, for example, price comparison websites, and this is a very sort of simple example, but more sophisticated of examples of an AI assistant on your iOS or whatever it is, being able to know you and predict your weaknesses and counteract them so that you make better decisions as a consumer. It's a somewhat speculative claim, and it's not clear whether that would fully be capable of overcoming the creditor's informational advantage. And the one thing I'd be concerned about are new agency risks. So where the platform or whatever the digital assistant is also has obligations to the other side of the market, and I'm thinking of advertising or fees from suppliers. So Ian spoke yesterday about an agentic shift, which I agree with, but in this context, I wonder whether the ultimate principle is the assistant or the assistant's owner or their principle, right? And it's not something that can be measured with precision right now, but these are just dynamics to be considering. The second shift I see is between creditors, between firms. And this has a kind of antitrust competition dimension as much as it is specific to information and credit markets. So right now you have obligations that are largely voluntary for creditors to share information via a credit bureau. And the purpose of this is that you want to mitigate the risk that you get a borrower who is a bad credit risk but you didn't know. So it's purely an information function reducing adverse selection moral hazard effects. The other side of this is that the credit bureau compiles this information into a credit report, which is used for the consumer. So there's a kind of consumer empowerment education function as well. And the question is that as lenders turn to using more and more sources of data, more complex data, larger data sets, can the existing information sharing framework still be fit for purpose? Where typically a bank will send a batch file at the end of the month, and it's data relating to the particular creditor, to the particular borrower. Can you really be sending sentiment analysis from Twitter, or can you be sending demographic data that doesn't relate to that particular borrower? How would you communicate that? And then in the hands of the credit bureau, how is that communicated in a credit report? How could you meaningfully tell the consumer what information the creditor is using to reach a credit decision? So this is a kind of new shift. It's related to the sort of antitrust question of how much this is affected by access to data generally, and whether, on the one hand, there are increasing returns to scale. On the other hand, you could say that much of alternative data is more easily accessible than perhaps private credit data. And maybe if you start building in things like synthetic data and other ways of training algorithms, then the access to data might not be as much of a competitive advantage as we might think, but there are definitely two perspectives to that debate. In the interest of time, I'm going to just briefly cover the other two asymmetries, and there are more. I mean, the third asymmetry, which I sort of try to illustrate in this diagram, is that between the regulator and the regulated party. And there's a sort of risk, which is that as you use more and more complex machine learning and more complex models, it'll be harder for regulators to understand how these decisions are being taken. Sort of overlaying all of what I've just said is this sort of kind of general asymmetry or information dynamic between humans and machines. And in this respect, we can think, okay, for example, a very opaque deep neural net, which we don't know exactly how it made its decision. But also more generally, machines between themselves being able to communicate. And we've seen in reports of like Facebook's chatbots that were shut down because they had their own language, or there was a recent report that you know, a Google Assistant could interpret cocaine noodles as OK Google, which none of us would have interpreted the same way, right? So there's a sort of a possibility for humans not even interpreting the machine, and that's in itself a manifestation of an asymmetry of information. So we've covered what are the benefits and what are the potential risks of these shifting information dynamics resulting from the use of machine learning and big data. In the last couple of minutes, I want to just briefly introduce the regulatory part, which is the third part of the paper. And you know, I'm looking at the EU and the UK, but over time I would want to bring in more comparative perspectives, particularly from the US. And as you can see, the regulatory framework for credit scoring is, you know, multipolar. There's financial laws, there's data protection laws, so you've got the general common law, you've got voluntary standards. I'm not going to go through the analysis of each of these aspects to say, you know, to what extent it can stand up and to what extent there are weaknesses, but I'm going to highlight sort of 4 general challenges. The first is that I see an increasing weakness of information-based regulation as we turn to more highly data-driven and complex data in decision-making. And if you could even look at the Consumer Credit Report as an example of this sort of disclosure, and what I described was an inability to really effectively communicate how a decision is taken in a manner that's meaningful for the consumer, and more of a meaningful enough that the consumer can correct it, which is part of the function of a Consumer Credit Report. The second challenge is I see a move away from personal duties of care towards more organizational duties of care. So in the financial sector, you sort of have, this is an example relating to financial advice, so that the financial advisor is a fiduciary and has to act in the best interests of the client. Now, how will it be possible to demonstrate that they provided advice that was suitable to the client? Similarly, how will we demonstrate that a credit scoring process was proportionate? Instead, we're seeing a move towards more organizational duties, for example, to ensure that the algorithms are audited, that the data meet certain quality assurance measures or standards, which is a shift. It's a subtle shift, but it's a change in approach when it comes to regulation. Thirdly, the move towards, so the current reliance on more of an outcomes-based approach, at least under UK regulation, could become more vulnerable to the extent that there are potential harms that are so large that left to an outcomes-based approach, they would cause too much harm before being addressed. Does that mean that we move towards a more ex-ante approach where you prevent, for example, certain types of tools being used altogether? Of course, that has its own costs because you cut potential benefits, so you can chill innovation before prematurely. And then lastly, I think it's important to think about the interagency cooperative aspects. As you know, the GDPR has significantly increased the enforcement powers of data protection authorities, and the ICO in the UK at least is a small agency with not many people, which now has many more responsibilities and powers. The question of how the new regulation and the new sort of emphasis on data protection and the inherent role of data in the financial sector means that there needs to be a new framework of cooperation between the financial regulators like the FCA and the PRA and the ICO. I may have just a minute to briefly highlight a couple of solutions, and there's been discussion about more personalized disclosure. So the idea that these insights could be used to actually make this disclosure tailored to the particular behavioral biases and needs of the individual consumer. Another thought is decentralizing information. So whereas the credit bureau represents centralized information, there are a couple of companies that have filed patents, so RBC and JP Morgan, for credit chains, which is basically the idea of holding all credit data and any data on a consumer on a blockchain, which is accessible by any lender. You know that the Second Payment Services Directive also sort of opens up this idea of moving data from one lender to another, and in the UK that's been implemented in the form of open banking. And then thirdly, to say that, well, financial regulators have quite strong data gathering powers, and it might be that they need to exercise more of these in order to know what firms are doing. That's all. Thank you.
Fantastic. Thank you, Nikita. In hindsight, it seems that I've confused Confucius with consumer credit, and again, apologies for that. Let's open now for questions if there are any. Yeah. You go, Marco.
So this is almost more observational than questions, but that's fantastic. This project looks fantastic. I can't wait to read the paper. So the first observation / question, I think it's interesting and counterintuitive when you say that this type of technology makes information disclosure a less effective way of regulation, because of all of the regulatory calls for transparency as an effective form of regulation. And I guess going back to, this is a question, going back to the project that I've been working on, because information disclosure is such a central component of light touch governance or collaborative governance, and collaborative governance is often touted as being something that's more effective for dealing with highly complex technology and evolving technology. How do you reconcile your thought that this type of technology is exactly the kind that makes information disclosure less effective with the call for using that kind of collaborative governance approach for this type of technology? And I had a second question, but let's just do that.
Thanks, Margaret. That's a really interesting question. I mean, I think it is a dilemma, right? Like, it's not. I struggle, or I'm skeptical about the role of information disclosure in general, and I think that as the decision-making process becomes even more complex, there's and also that the firms have more access to information about the consumers. I'm skeptical about how effectively just disclosing what's being done is really going to prevent irrational and suboptimal behavior by a consumer. So there's a limit to how much the consumer can process, and really like how effective that is.
So I guess my only thing to, without having read the paper, I can't tell whether this is going to be in the paper, but one thing I'd push towards is information disclosure obviously is like a far broader concept than just the disclosure to an individual about a decision. It's also the types of sort of systemic governance things that you're discussing about auditing, third-party auditing, et cetera. So maybe the claim then isn't that information disclosure is less effective, it's that individualized information disclosure will then shift to sort of other forms of accountability mechanisms that still involve disclosure, but to different types of entities.
Yeah, no, that's right. And when I'm thinking of individualized disclosure, I'm thinking of mandated disclosure in the context of, like, you know, the sort of investment disclosure. That's where the sort of origins or sort of SEC type context, not so much an impact assessment that becomes public, which is which it's disclosure, but it's not the kind that I'm necessarily sort of conceptualizing. But yeah, I mean, it could be that there's more of a need for a regulatory, sort of stronger regulatory solution that like either preempts manipulation or abuse, or for example, a kind of not-for-profit or a regulatory platform that alleviates that gap, right? That this sort of consumer helping platform is kind of essentially socialized in a way that it's publicly provided a service.
Great, we have a question here.
Thank you so much. That's incredibly interesting project. And what I wanted to ask you about is whether do you have any data about what are the consequences of this being used, or whether it is actually being used? Because I mean, linking somehow to Margot's presentation yesterday about different rationales of why we would not want people to do that. Now you can look at it from, say, utilitarian perspective and say, okay, there are some good, bad consequences that use of this technology leads to, which is, for example, people who would get credit because there is some alternative data about them being late for meetings, whatever, did not get it. Well, maybe they should have. Or on the other hand, you might say, okay, there are people who are unbanked, maybe not in UK, but in other societies, and thanks to the system, they are getting credits. Or you could just take a deontological approach and say, even if there is some benefit to get from that, I really don't want credit companies to like know who I'm meeting or what I'm watching on Netflix or whatever. Like, that's really not their business. And I guess we need to reconcile that in one way or another. So I'm just wondering, do you know, like, do we have any data on how many % of people who otherwise would be refused credit got it, or how many people who ended up being really the ones who could not pay back, even though from their banking data, so their standard data, it seemed they would, or is it still just speculative in a sense that we know this might be happening, but we don't really know the numbers.
Yeah, thank you. Obviously, it's like an early stage in the use of these approaches. So empirical proof or long-term experience and evidence is obviously somewhat limited. I mean, what we do have is anecdotal / empirical evidence from lenders who are using more sophisticated credit scoring approaches to show that they have lower default rates, for example, which is a kind of direct measure of, you know, what is the credit risk of the borrower. So those are examples, and you know, there are many platforms and lenders that are using it and have seen lower default rates. Whether they can associate it specifically with the credit score or some exogenous factors, we can't really say that, but at least anecdotally we have that evidence. And also there have been studies done, and then they're not necessarily that recent, but studies using, say, machine learning neural networks for credit scoring models on historical data sets to show that if you were to use these different approaches, how you could change the error classification rate, so risk of false positives or false negatives, and it becomes lower. Not with every method. In some cases, traditional statistical approaches are actually more effective, but as you get into more kind of high-dimensional unstructured data, it does become more effective to use those. But again, that's on historical data sets. But they're indicators.
And there is a question at the back. Is there anyone with a microphone, perhaps? It's really late, I know.
So thanks a lot for the presentation. It's an amazing project, I think, in the light of the financial crisis that we are still going out of in Europe, that originated with the mortgage crisis in US. This is something tremendous. I was wondering if you could add another dimension to the main one that you described, because I see the main one as quite intrusive on consumer and data protection privacy. If you could add the dimension that would be more positive in terms of protecting of consumers, for instance, by trying to see if AI could be used to not to test just the consumer, but also to test if the lender could structure the contracts better, so to give more flexibility or to adjust them more to the needs of the consumer. For instance, when they analyze the situation of the consumer, and the consumer gets into trouble or might get into trouble, that the consumer could get a contract that is providing for flexibility in repayments, or for some periods when repayments are freezed, when the consumer gets back on the feet. You know what I mean? So at the moment, it's more like testing the consumer if there's a threat on their side. But if the machine learning could be used in structuring the contract better, so that if there would be problems on the side of the consumer, that we have intelligent solution on the side of the lender, rather than just disruptively closing the contract and elevating the interest rates and the sort of tools that were used 10 years ago and led to the crisis.
Yeah, thank you. So I think I brought this up, but the point is that, actually one second. So the point is that this is a double-edged sword. The access to these insights could be used for good or for bad. And the one scenario is the one that you sort of want to see more of, which is that, okay, now you have all this personalized information, you have many dimensions about the consumer to measure their preferences, to measure their behavior, and you can design a perfect contract. For example, let's have dynamic penalty pricing, so as the consumer starts to sort of slip back and they're falling more into arrears, we increase the, well, you can imagine many ways in which it could be specifically targeted at the consumer. And that's, I think, a benign scenario and an efficient scenario. But there is also the risk, which is one that's we've seen in markets, not just in credit markets, time and time again, is that the information is not not always used for good purposes. And where the lender knows that they have this informational advantage over the consumer, why would they not instead, especially if there's more money to be made this way, use it to, for example, make the contract look very attractive along salient dimensions like price, and then hide some unattractive terms in the fine print of the contract. I can't say which one will pan out, but based on experience over time with misleading advertising or whichever example you want to choose, there's always a risk that the negative scenario plays out.
Great. Thank you, Nikita. If there are no more questions, let's move to Francesca and Giuseppe.
So hello everyone, thank you for inviting me here, and I will present this work. It is a work on which Francesca and I have been working for a little time, and here we present some initial results. Do we have the... Yeah. Okay. Well, so basically we are exploring how to move the next one. Okay. So basically, in our presentation, we are analyzing the liability issues of evidence-based clinical decision support systems. So as an example of one of the systems that are currently being experimented, and that in the future will be probably implemented in the healthcare system, we are taking the IBM Watson. As you know, the IBM Watson is based on this deep QA technology, and probably after 2 days of conference, you have a basic idea of how this system works. So basically, deep QA is trained on an initial data set to establish correlation between questions and answers. On the basis of that, the system is able to provide a list of candidate answers when requested to provide an answer to a question. And in doing this, the system will analyze and extract information from a large data sets of documents, previous cases, and data. In our case, when applied to the healthcare system, the system will be used mainly to identify a possible diagnosis and to suggest a treatment. And the documents that will ground this decision will be documents concerning previous cases, previous treatments, other patients, the literature, and so on. So, what are the characteristics of Watson? Again, here I'm saying things that probably after 2 days you can already have an idea of. So, of course, we are not talking about expert systems like in the past. So, instead of having the manually encoded knowledge and procedural algorithms, here the system is based on machine learning, data mining techniques, and on algorithmic decision making. This system, we can say, is basically unpredictable, but as someone will say, it is not a bug, it is a feature of the system. It is unpredictable by design. Why it is unpredictable? Because the answers provided by the system are based on this enormous data set that is constantly changing, and it's also changing the internal configuration of the system. And that is very large, partially or totally not known and not available to the programmers and also to the users. Because of these features, let's say, the output of the system cannot fully predict. Besides, also the Watson behavior, internal behavior, cannot fully explain it. Of course, not only with the reference to the lines of the codes that constitutes his program. However, this system has a stronger impact in practical terms on the decision-making process carried out in hospitals. Starting from one consideration that many experiments tell us that decisions taken by Watson are more precise than decisions taken by human doctors. Therefore, starting from this consideration, we can start to have an idea of what are the main legal and ethical issues related to the use of IBM Watson in the healthcare. The first problem is the legal qualification of Watson, of this system. The second problem is to identify exactly what is the role of Watson within the healthcare. What is the role and what are the tasks that we expect from Watson to carry out. A crucial point on this regard will be also the liability for accident caused by the use of Watson. How all the actors involved in the healthcare will share or not share, will be allocate part of the liability resulting, for example, from an accident in which the decision taken by Watson has an importance in evaluating the accident itself. The last problem is the problem of accountability of transparency of Watson and similar system. If I have time, I will spend some words on this, but I think that it is an issue that has been already discussed during the conference. So the first problem is the legal qualification of Watson. According to our research, Watson would not be considered as a normal product, but would fall under the definition of medical device, software as a medical device, under the rules of the old Directive 9342 and the new EU regulation 745 of 2017. First of all, we have a problem of classification because according to the rules of these directives, Watson, in our opinion, would be classified as a low-class medical device in the sense of a low-danger, low-risk medical device. This because automation and the capabilities of these kind of systems of interfere with the decision-making process are not taken into account in the regulation. So the distinction maybe is between active and passive devices, intrusive, I mean devices that can interfere directly with the body of the patient and not interfering with the body of the patient. According to the classification, therefore, Watson in some ways is not considered very dangerous, and therefore also the procedure to obtain this conformity assessment in front of what is called the notified body, let's say a sort of certification body, will be basically a set of information provided by the producer itself, ensuring in some ways the quality of the product, but not the full quality assurance, following the words of the old directive, of the full product verification according to the words of the new regulation. That would instead require a deeper analysis and validation carried out by the public body on each individual exemplar of the technology. In any case, this kind of legal qualification would be relevant in establishing the level of safety, the expected quality of the product, and also the liability of the involved actors. For example, for the producer, they may be relevant to establish the defectiveness of the product with regard to, for example, the design defect, and particularly also in case of a future reanalysis of the classification in which we would have a full product verification, also the product defect. On the other side, they would be also relevant in assessing the liability of the user, let's say, the medical doctor using the system, depending on whether we think that this kind of conformity assessment would result in providing to the user, in creating to the user a sort of legitimate expectation, so that the expectation that the system, by the law, following the law, is considered to be a quality product and therefore safe because certified by the law. The second problem is the role is understanding the role of Watson within the healthcare. Because, of course, Watson let's say, replaces the doctor or support the doctor in some of the tasks that we usually associate with the role of being a doctor, in particular with the tasks of making a diagnosis and selecting a treatment, which means tasks that will probably be associated with some responsibilities that may result in legal liabilities, and some of these responsibilities will include also the responsibility of providing an explanation. We expect a doctor to provide an explanation on why a particular diagnosis has been identified, why a particular treatment has been selected, and so on. The problem is that when we think about Watson, when we understand the functioning of Watson and evaluate it from a legal point of view, we cannot adopt the same perspective. Let's say what Dennett would call the design stance, because basically what we can expect from Watson is not to provide a complete, full explanation of the decision. It's part of the way the system is designed, the fact that we cannot expect such explanation. So we will look at the functionality of the performance of the system. So to the fact that its rate of success at performing particular tasks, in our case diagnosis and treatment, seems to be good. So the system seems to work. 3 minutes, wow. Very strong time. So basically, this is something that it is not new in the healthcare, in medicine. So we have the evidence-based practice. So the idea that if an action produces a good effect, then this action is justifiable. And therefore, if we start from the fact that basically we know that Watson works and works on average better than doctors, we should conclude that doctors, they should be bound, they should have an obligation to use Watson because of its performance. These things that we have discussed will have an impact, of course, on liability, because we should ask ourselves at this point whether or not Watson is only a support to the doctor in taking the decision, or otherwise is taking the place of the doctor in taking the decision. So the decision authority probably is moving towards the system. The argument could be that from a practical point of view, it will be impossible for a doctor to completely assess the decision taken by Watson. First of all, because we don't have the explanation. Secondly, because we don't have the access to the full source of documents processed by Watson. And therefore, and probably also the time and the resources for the doctor will be also limited. So probably the doctor will be, from a practical point of view, not in the condition to really oversight the decision taken by Watson, and simply, as the Professor Simoncini also said this morning, will simply rely on the system, on the decision of the systems. Also because there is this legitimate expectation probably that the system is working. Depending on the position we take, on this regard, on the fact that we can configure this legitimate expectation on the system, we can have different consequences on how we evaluate the decision, the liability of the robot, or the liability of Watson, and of course of the actors which are behind the development, the maintenance, the design of Watson and of the doctor. And in particular, one of the reasons to allocate reliability, one of the ground under some assumption could be also the fact that the doctor did not follow the system's suggestions. One open question is, because here we have another actor, but that sometimes is in some sense forget, the patient. Has the patient a right to know that the doctor and Watson, for example, in some situation have different position on a particular matter? Has the patient, in the perspective of the informed consent, the right, for example, to opt-in, opt-out from Watson, for example, to ask the doctor to follow the suggestion given by Watson, or on the contrary, to disregard any suggestion given by Watson? In order to better analyze the issues of the use of this kind of highly automated system, we found in previous project very useful to refer to the taxonomies adopted to analyze the different levels of automation, because we know that automation is not present in any device product in the same way. And for example, according to this taxonomy, which is used in many domains, in particular in aviation, the level of automation taxonomy, you can look at four cognitive functions that may be affected by the use of automation: the acquisition of information, the analysis of the information, the selection of the action to be executed, and the implementation, I mean the practical execution of the action. According to our classification, the level of automation of Watson when deciding, when making a diagnosis and deciding the treatment will be very high. Now we don't have time to discuss this. The most important phase in which we have a particular interaction between the doctor and the machine, of course, is the phase of decision. The phase in which we have, let's say, a division of tasks between the human and the technology, in some ways are also the most dangerous, even from a legal point of view. Why? Because it is true that part of the tasks have been delegated, but in this particular phase, the phase of the decision, the tasks will be very fragmented between the machine and the human. And new tasks will emerge. The tasks of, from both the two parties, make the interaction work in the correct way, which translate in legal terms, on the one side, for the producer of the technology, to make sure the technology, for example, is able to inform correctly the doctor about the decision. I mean, to communicate the decision in the best possible way. And this will have an impact particularly on the risk of defect, of the defectiveness of the product, for example, under design defect in particular, and possibly also on product defect. Another problem will be to make sure also that the user, the doctor, it is not only trained on his main task, like to be a good doctor, but it is also she is trained also in using correctly the system, which means an increased liability on the doctor and on the training in general. So who within the healthcare is in charge of training the doctor. And then an increased liability risk also on the producer for what is concerned with information defect, which means the liability of producing, for example, manuals or explanation on the functioning of the product. So there is a huge space here for the legal analysis, in particular of this complex interaction between a human doctor and, let's say, something that is a sort of robotic doctor, but which does not speak the same language of the doctor. So the interaction is very complex. Thank you very much.
Thank you, Giuseppe. Really interesting stuff. One thing that that kind of captured my attention is you used the phrase obligation to use Watson if, let's say, we find out that the results are better than human. And coming from the STS background, it's really interesting because we often consider how the lockdown or kind of stabilizing or closing down of technology happens. And as a matter of fact, there has been some controversies with Watson delivering really results that that engineers promise. So an interesting kind of point, more a comment than a question. But let's open for real questions. And yeah, yes, please.
Yeah. So you know, a great project. This is more about how to frame it. You know what I mean? In many ways than in the content itself. So this paper seems very much in dialogue with a series of papers that Ian wrote with Jason Miller and then later with Michael Frumkin. And I wonder if you shouldn't just expressly frame it that way. Do you know what I mean? Like if you have a different take from these authors for a particular reason, or if you're bringing to bear a comparative perspective, I would just frame it as being in dialogue with that, because I think that would really enrich the project and use it as a provocation for you to, you know, and that's often how, you know, in this in the burgeoning, you know, robotics law and policy community in the United States, you know, one of the benefits we have of having an annual conference, which maybe this will become, Giovanni, vediamo, but, you know, but what we have is we have this dialogue with each other, and it would be great for you to plug directly into it. So that, maybe, is this a framing question more than anything else?
No, absolutely, because I think that we came to look at the works of Miller's, I think twice, because it was the first time we worked on developing the ethical knob, and it came out that he had similar positions to the stance we took in the paper, and here now with the work we are doing on Watson. Yes, so absolutely, I think we should in some ways, yes, put our work in combination, combine in some ways.
Let's hope indeed that this becomes an annual gathering then.
No, absolutely.
If we do we have more questions? Or maybe Fran, yes, please, Lana.
Thank you. My question is maybe not completely directly related to your topic, but I was wondering if the EU GDPR would actually apply to systems like this that make medical decisions, because from my understanding, it's partly out of the scope of EU law, those questions, and they're still largely a national competence. So articles like, you know, the necessity to explain the software, would that actually apply to those types of medical systems? Thank you.
I think that with regard to the second point, for sure, we need to apply the same principles. But yeah, I mean, I'm not an expert on these issues because I'm more on the criminal liability side, and my analysis pertains more to this point. But if you mean from the privacy perspective and also to the accountability and principle and transparency, yeah, I think for sure that it should be, but it's a little bit complicated. In particular, these systems, basically, there is not a real explanation because I mean, the possible diagnosis that the systems gives as an output are scored on the basis of statistical, on a statistical basis, and I think that in this case it could not be seen as an argumentation and an explanation as we, need in the medical domain.
Yes, this I completely agree on the part of the, let's say, the explanation. Concerning the full automated process, here I think that the process will be not fully automated in the sense that we still would have the doctor. Of course, we are questioning whether or not the doctor is actually in the position to have, I mean, evidence to counter, to attack the decision taken by Watson. But according to interpretation of this problem given by the Article 29 Working Party, the doctor will still be in the position, will be still legally in the position to reverse the decision taken by the system. So it would not be a fully automated decision. So at least it will be possible, I think.
Yeah, but if I may, I also think that sometimes it's difficult because there are some decisions that are constrained by time and emergency, and so there are some, I mean, it's a particular kind of application. And yeah, I would say also that it's true that I think we need in some specific domains the human in the loop, especially with regards to maybe the last, I would say, cognitive functions and the possibility of delegating such tasks to machines. But yeah, I think that we need to have human in the loop, but sometimes this could be a problem from the liability assessment perspective, because I mean, there is also a problem in this case, for example, of influence of the system and of trust in relation to the decision-making process made by the machine.
We have. There was one question before, yeah, and then turning over to you. Yeah.
Thank you. I have sort of two related questions, and the first one is a follow-up on Ryan's question, and the second one is just more of a curiosity question. So I'm quite flattered to see so much of the work that Jason and I did in inspiring sort of the question that you're looking at. And just as someone who hasn't had the benefit of seeing your paper, I'm just curious to know where you see the main points of disagreement, or where you diverge from our paper. From what I could tell, it came down to the considerations around that chart with the 4 permutations, but I don't know if you can enlighten me a little bit further on that. My second question is, so the follow-up work that Ryan kindly referred to, which I'm about to publish with Michael Frumkin, which we presented this year at the We Robot conference at Stanford, and which is available on SSRN. Our original title was actually Dr. Watson versus Dr. House, and the reason, and we were going to present the work under that title at last year's We Robot, but for various reasons we ended up presenting it at this year's We Robot. And the reason that we had chosen that title was because of what we saw as this moment of human-robot disagreement and the tensions that arise as Watson gains more and more evidence-based credibility of being a better decision maker or diagnostician than Dr. House. But then you have a Dr. House type character who's more of a humanist doctor who doesn't want to just follow the algorithm blindly, but has their own intuitions about how the case should go. And then, of course, the questions about how hospitals as institutions and how the legal system as the maker of rules around medical malpractice come together in this sort of complex play to see how these things work themselves out. So I was just curious because I didn't see how Dr. House figured into your title, and I'm curious to know sort of what you're thinking and what your take on that was, because I found it very interesting.
No.
This got to a whole new level of interesting, but because of time constraints, we'll gather 2 more questions that we have, and then if you could respond.
So I've heard numerous people in events such as this pose the question of whether we should be setting exams for the AI machines and whether these should be the same as the exams that humans, so should they pass the bar exam, for instance, and should that be the same as what the humans have to pass, or should it be one that's tailored to a machine specifically? So I just wondered what your thoughts were on setting exams for machines to have to show that they pass before they're let loose on the public, just like the human experts themselves have to pass.
Thanks. It's not a question, just a comment regarding Article 22 that was mentioned before for GDPR. I think that we are in a situation where there is an exemption of the paragraph 2, because I think that we are in a situation where you can apply the exemption of paragraph 2 of the Article 22. But at the same time, I think that it's really important, the paragraph 4, when you say the fact that you have to adopt measure to safeguard the interest of the data subject. So I think that it's a really important point what was raised by Leonard.
Well, the first thing, the title of the paper, we were completely not aware of the work. We are sorry. We will probably change the title at this point because.
Just to be clear, I don't think people own titles. I don't even think the intellectual property law. But I'm just sort of curious, what was the motivation for your title?
The motivation is that while when in previous systems, let's say in systems based on procedural algorithms or expert system, etc., we simply reproduced in some ways the reasoning process. In some ways, we simply formalized the reasoning process carried out by a human. So I provide a justification on the grounding it on a sequence of reasoning steps. So we have the expert systems that at the end provides with the justifier the decision, blah, 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 blah. This is the solution because A, and A because B, and B because C, and so on. Instead, and probably this is the way that also a human doctor would work. He would carry out the reasoning as a lawyer, starting from the evidence and using not the legal rules, but the laws, let's say, of medicine, and producing a diagnosis and so on. Instead of the system, of this kind of system like Watson, what we see is the evidence at the beginning and the results at the end. What we can say is nothing about the design itself. We cannot judge very much what's happening in the middle, as we already say, they are a black box, they are difficult, they are inscrutable in some sense. So at the end of the day, what remains to us to assess the quality of the results is just to say, well, after all, they work, and they work well, they work better than, let's say, the average doctor. Therefore, we should use it, and that's all. And of course, is a different way of evaluating the work of, let's say, the fulfillment of a task than the way that we will adopt with a human being. So this is the problem in our sense. So on the one side, we have a human being, let's say the Dr. House, because he's a famous doctor, and we are used to think to his work, to his role, his tasks, and to assess them using this kind of parameters, reference to the quality of the reasoning process, taking account the information that the doctor had in the moment in which they took the decision. This is what a reasonable doctor would have done. And instead, on the other side, we have a system that is considered to be statistically good. Besides, in Europe, we have probably a certification coming from an authority saying the system is good at the same time. This is a sort of conformity the conformity assessment done with the directive and the regulation. And this would change, in our opinion, at the end of the day, the relationship, let's say, the reallocation of liabilities between the human operator, in our case, the doctor, and the technology, or better, who is behind the technology, in a system in which we have not only these two actors, we have the patient in the middle, which has some rights, which intervenes in the decision-making process. At least in Europe, in Italy, we have this concept of the informed concept. So the right to an explanation. So we are wondering what are the information that should be transferred at this point to this patient, when we cannot say to the patient anything more than the fact that Watson is good at providing diagnosis and treatments. And so these are the things, basically. That what we presented is this sort of sketch. We had this law at the level of automation taxonomy. Is a taxonomy that we have used in a quite long project, 6 years project in aviation. And we used it as a part of a methodology for that we developed for called the legal case, to assess the legal risk in relation to development and use of new technologies. So we reapplied this methodology. We are reapplying the methodology on Watson to see how the reallocation of liability would work and whether or not the results are good for the actors involved and for the efficiency of the total system. The first results are, as I said, that probably there should be a huge investment in making sure that the manuals that specify how the technology should be used are very good. The manuals that are at the end of the day provided to the doctors. That guidelines should be provided, but here we are a problem. The more the guidelines leaves margin of discretion to the operator, to the doctor, the more we are creating a space again for his or her liability. The more instead the guidelines are stricter and rigid, the more we limit the liability risk, but we risk to create inefficiency for the safety of the whole system.
Giuseppe, I'm very sorry, I will need to cut you here, and this discussion, however fascinating, will have to continue in an informal setting. And now let me ask Leonard to present the last presentation of the day. The floor is yours. All the time in the world, as long as you finish before 4:45.
Okay, thank you very much for having invited me here. It's a great conference. So the topic I want to talk about today is where is the law? For example, earlier today, Katie Atkinson, during her presentation, mentioned a publication that was called Making Autonomous Vehicle Respect Traffic Law. And my question is, are robots actually following the law, even when the autonomous vehicle does stop at the red light? Can we consider that it is obeying the law? So my argument is that we cannot consider that robots cannot be considered as either law following or law breaking. And the reason is that in the robot, essentially, there is a confusion between different modalities of constraint, and that would be the law, the architecture of the algorithm, and the product it creates, and other modalities of constraint. Because, of course, we as human beings perceive that difference. We are impacted differently by law, by social norms, by architecture, for example, on the internet, or even within cities that constrain the types of behavior we can have. And this has consequences for the attribution of responsibility. Also, it has an impact on, in the debate about granting legal personhood. If robots are essentially not making decisions according to the law or against the law, then it becomes more complicated to justify that we give them a legal personhood. So, translation of law into algorithms. It's just that essentially when you launch an autonomous vehicle on the streets, you need it to stop at the red light. You need it to respect traffic law. So in some way or another, you have to embed our regulation, our traffic laws into the machine. And right now, there is 2 ways of doing that. You can either have rules that are generated by human beings at the stage of the creation of the algorithm. So the learning algorithm itself possesses the symbols and the rules that force it to stop at the red light. So those types are more determinative than the ones that are generated by machine learning. Because they have an impact, a weight that is prohibitive, I think, from what I understand at least. But I would argue that even when those are created by humans and they have this bigger weight, the rules are not semantically different from designed behavior. For example, if the same autonomous vehicle has the task of picking up the trash on the streets, those 2 rules may have different weights. Obviously, the stopping at the red light should be more important than picking up the trash, but I don't see the robot seeing any difference between those 2. They're just 2 modalities of constraint on its behavior. When it comes to machine learning generated rules, so those come from data. So basically, the machine learns by observing data that this is the behavior it has to adopt. Eventually, the results are verified by human engineers to make sure that the robot is efficient at what it is doing. And I would argue that robots will not be commercialized unless they have a significantly high percentage of respect of rules and other elements. So here, it's even harder to see the difference between the rule, the law, and the designed behavior or other elements that impact the machine because partially of the black box problem, although this is not, it doesn't seem to be a problem that is going to be there forever. But here, because it's impossible to access essentially the rationales behind the creation of those different elements within the machine, it becomes even harder to make a difference between the different elements that impact the behavior of the robot. So when the robot generates by itself the rules that it has to follow from the data, those are even more similar to picking up the trash than from the ones than rules, translations of regulation that are generated by human beings. So the second thing that is, so the first thing that is lost in translation, so to say, is that the conceptual difference between law and other modalities of constraint is lost. The second thing that is lost, I think, is what I call the legal implicities that are lost in translation. For example, the article in the French Penal Code on rape would read, when translated, that any act of sexual penetration, whatever its nature, committed against another person by violence, constraint, threat, or surprise is rape. Rape is punished by 15 years criminal imprisonment. And in that rule, there are a certain number of legal implicities, things that are not defined by the article. I think that the first degree are the professional implicities. So that's basically the lawyer's job, knowing case law, knowing the legal definitions for terms, which are also missing for most human beings, most layperson. This is not, because those are not understood by general human beings, I would say that they're not so important. it's not so important that this implicity is lost. But yeah, the robot doesn't necessarily need to know what constitutes violence according to French case law. But I would also argue that this is probably the type of implicities that are easiest to implement within the understanding of the robot. The second types of implicities that are lost are the ones from natural language. And although, of course, we make a lot of progress in finding, in creating a natural language processing for robots, but still, I think the robot doesn't necessarily understand, has the same understanding we have of what terms like sexual, person, and 15 years have in that article of law. The third implicity that is lost is conceptual meaning of words. For example, when the article mentions person or individual, well, we have the understanding that individuals are different entities, right? That we're all different persons, and that's something that seems very hard to translate in the machine. That human beings are actually different, unrelated entities, not connected, not like machines would be on the Internet of Things, for example. 15 years is also correlative to human existence, to our mortality, and it's again something that would be meaningless for a machine that doesn't have a conception of mortality, what 15 years mean. There's also, of course, consequences of imprisonment at the social, at the professional reintegration level. All of those conceptual implicities are lost in the translation process. Or at least it would be pretty hard to either hard code or have the machine learning understand. It is also and even more than that, we don't even know ourselves what all the implicities of the law are, what all the effects of the law has into pushing us to comply in a certain, to behave in a certain way. And we can't even chart all the effects that law has on the human brain, on our behavior right now, because neurosciences are still quite limited. So I would say that the main thing is that there is a conceptual indifference between law and design behavior and other elements that influence the machine in its behavior, whether it is generated by machine learning or human generated. Rules coded either way are not different from design behavior, architecture, or social norms that we would put on the robot. All the modalities of constraint become semantically indifferent to it. And the only difference that different rules eventually have, I think, is the weight, the normative weight on the behavior of the machine, how much it influences its behavior. So the consequence is that whatever is translated inside the robot from a human perspective cannot be qualified as law. And as soon as we recognize this, then we cannot say that the robot is respecting the law or disrespecting the law. And I think that another consequence, more indirect, is that if the robot is not disobeying the law, eventually, well, it's the human beings behind the robot that are more closely linked to the actions of the machine. For example, it becomes, I think, easier to blame engineers if the robot acts illegally, because they would be the ones responsible for making sure that the robot has effectively learned the rules it is supposed to follow. So, but it's at this stage, it's more of a feeling than something I have constructed very well. But yes. So there are a few caveats about this. Does it really matter if the different behavior setting functions are semantically indifferent? It is for us important, I think, that law is a different category from social norms, but does it really matter if those things are more or less the same for the robot, as long as it's behaving the way we want it to? And even if the robot is not deciding to conform itself to the law when it's stopping at the red light or not, does it really matter in the end, that more philosophical aspect, I think. Another caveat is about the limits of how much we understand our brain. I would say that Netflix is charting our brains right now by telling us what movies we understand. So maybe the machines actually can, on their own, through machine learning, understand all those implicities. And they might even understand stuff about us that we don't even understand ourselves. Yeah. Thank you very much.
Thank you, Leonard. Let's now open for questions.
Yes, a question for you. This is a very interesting topic from my standpoint. I would say just one thing. As you say, as you perfectly explain, it is very difficult for several reasons to put inside a machine a law which is really understood by the machine, basically. But what I want to say is that in order to, for example, keep the behavior of the machine safe, it is important to embed some laws in the machine, or it is more important to make aware the machine about the environment it is. I will say, if I have some kind of online risk assessor inside the machine, which is able to evaluate during time what is the level of risk which the action of the machine can expose the people, this is not law. This is basically something which is related to the possibility that the machine, for example, causes a damage to a person. What should be followed, the law or this reference, which is, let's say, assessed online, for example? That's my question. Thank you.
And I see a question here, and now Przemek has a question, and Nikita. And yeah, well, there's a lot of questions. Okay, let's go fast.
Hi, thank you very much for your paper. I totally enjoyed it. And I really, in particular, I've written some similar work on this, and I really, in particular, liked some of the way that your arguments work with some of mine. So I just wanted to mention the work in case it's useful to you. A couple of years ago, I co-authored a piece that's called Chief Justice John Roberts is a Robot. And the premise of the piece was that it asked people to imagine the Chief Justice of the US Supreme Court getting into a bad situation. It required emergency surgery. They cut him open, and lo and behold, they find out he's a robot. And then it raises the question, what does this say about the legitimacy of all of the decisions made by the Roberts Court? And so it's a hypothetical, it's a thought experiment that looks at what I think is a similar question to what you're doing, but from a judicial decision-making perspective. And in particular, it raises the question about in what sense can a robot be a legal actor, in this case acting in the pronouncement of laws, which I think is the other side of the obeying and disobeying the law, because it seems to me that in order for a judge to make decisions, she has to be able to follow rules in terms of previous decisions, at least in a common law setting. And so our argument was sort of primarily focused on the question of whether it makes sense to say that a robot can follow a rule, which I think is directly related here, which is why I mentioned this to you. Just to give you a snapshot of our position sort of relied heavily on theory, and in particular the theory of Wittgenstein, the philosopher, and Herbert Hart, the American legal philosopher. both of whom talked about the meaningful ways in which one can be said to follow a rule. And we argued, in essence, that robots don't follow rules. So I think it's right on point to what you're doing, and I just wanted to mention it and to commend you for your work, and I look forward to seeing a draft of this paper, because some of the arguments you make are I think, really important in the sense of the concrete considerations of current machine learning, which is your focus, whereas our hypothetical was even trying to make a harder argument for ourselves by saying, let's imagine the robot has a lot of the capacities that you're not willing to give to the robots because they don't have them. So I think there's some really interesting overlap and also some really interesting juxtaposition. So I'd love to trade papers with you.
Thank you so much. I think that's an extremely interesting presentation and very important subject, since indeed a lot of laws that we have are expressed in language which is by design unformalizable. No? A lot of times the lawmaker actually chooses to use a vague clause or a vague term or a general clause, particularly for the reason that the moral agent at the moment of taking a decision should, taking everything else into account, decide on what to do. 3 comments rather than questions. I will end up with a question, but if you're turning into a paper, I think just as much as this is a very important subject, I did find your choice of examples peculiar. Starting with the question of whether a robot can be told to infringe the law or not, and linking it to the personality for robots, I really think that this is a no-go if you want to do law. No, it's an interesting hypothetical question if you want to do some philosophy, but this of course you can do, but I think there are much more important things to do, which is, for example, demonstrating to engineers where exactly are the problems or untranslatable legal concepts. And to take the example that you gave, I really can't imagine why would it matter whether a robot can understand what 15 years or prison mean. No? Robots are obviously not following the law or are obviously not infringing the law, but what they are obviously doing is they are performing actions that are not legally irrelevant, in a sense that if they were performed by a human, we would consider them lawful or unlawful. So there is a philosophical question that we could set aside, but there is an actual social problem, which is that the robot might infringe the law. The particular legal question you put at the table, okay, we might really not be able to formalize the concept of violence or formalize the concept or the other concepts, but just trying to imagine a robot that could actually engage into the act that you refer to, I think this actually would not be that very difficult to formalize what it should not do, right? I mean, it should just have a green button that you press. And this leads me to the last comment, which is what you said, that there is not that much of a conceptual difference between law and a task. I think if it's a positive thing, so a law tells you to do something, then maybe indeed it will be very similar, no? But consider an example, say, of algorithms processing personal data for a particular reason, no? So you have an algorithm that is supposed to deliver ads, or algorithm that is just supposed to collect the data and find patterns. It has a task, no? It has a task to see, okay, so people with what search history click on what articles or on what ads or what products, and then you want it to be compliant with law, no? So you want to say, okay, if we want to be compliant with GDPR, then do this is your task, but you should not process the data about political opinions, no? Or about ethnic origin, or about sexual orientation. And some of these concepts are by design open, like political opinions, no? If there is data that you like a particular political party, I know, finishing, Giovanni. That's fine. But if you think the taxes in the country are too low or too high, is this political opinion? We don't know, because it has not been decided. So, yeah, and the question I promised to finish with is, do you think there should be the same rules for humans and robots? And I would say not, because laws are for humans and for robots.
You not only managed to squeeze in 3 comments, you also asked a question and you answered that. That's perfect. So let's have 2 last interventions, and please short questions. Nikita and Bert, and then Leonard, you'll have an enormous challenge to answer all of that in a very short period of time.
Thank you. Just sort of an observation and maybe a recommendation. I think these are all really important questions, and it's really great that you're kind of thinking about it at a really deep level. I sort of wondered whether you might want to frame the question in a less binary way. So you say like obey or disobey, but the reality of the way in which machine learning is operating is that it's probabilistic. And I'm going to sort of just leave it at that for you to maybe think about, but like try to approach the question in a more statistical manner. If that might help the framing of the question, it might help you to think about whether laws are actually being implemented as opposed to obeying or disobeying. And an example I think maybe useful is when you think about speed limits, right? I mean, humans we don't follow speed limits. We always go above, for the most part, speed limits. But that's a accepted practice in how these laws are implemented. So that's something that the machine could learn from experience. It's scatological, my comments, but these are just thoughts I had as you were speaking that might be useful.
I have some literature suggestions, but I can do that offline. And I'll just briefly give one suggestion for reflection that you might help to develop your paper or a subsequent paper. That is that in legal theory or in lawmaking theory, you have a distinction between rules and principles. So you have rule-based law and principle-based law. And it might be interesting to see how your argument develops out depending on whether the law is very much rule-based or whether it's much more principle-based.
Thank you for all these comments and your question. So, if I understood your question correctly, Giovanni, is should the machine follow the law or should the machine follow morale in some cases, or phonetic decision making? I would say that definitely, if following the law leads to dire consequence for human beings, it's the second choice should be chosen. And I understand that this is definitely very important argument to make. But linking to also what comments were, is that I think that my point with this, I'm really sorry. my point here is more to destroy the legal fiction that the robot is following law, and that we can be done with this anthropomorphizing of the robot as following the law more than anything else. Thank you very much, Ian, for your recommendations. I'll definitely check it out. I think it is very relevant to also take the perspective of not necessarily singularity, but extremely general purpose, general intelligence AI, and those, because I'm intimately convinced that we're getting there. So if we can actually get some insight on this beforehand, I think that's definitely a very good way to go about it. I agree that 15 years of prison is not important for a robot to know. Also, all the elements that are given in the example about this article of the French Penal Code, I'm not making the argument that the robot should know about mortality and that the robot should know about all of these legal implicities. I think I am more trying to argument in the direction of making regulation that solely targets the human beings behind the robots and not the robots themselves. So it is important for us, 15 years of prison and all those other elements. They are important for human beings, and they don't need to be important for robots. But we shouldn't think that the robot understands it nonetheless. If we go with this fiction, this discourse that the robot is understanding what it is doing when it is respecting the law, then I think that the consequences we take from those kind of reasoning eventually are wrong and erroneous. So I'm just trying to destroy the legal fiction that is kind of being born that the robot is following the law. Should we have same rules for humans and robots? Well, I would say that we don't need rules for robots in the first place. We need rules for the humans that develop and use the robots. Creating law for the robots is, I agree, well, I don't know if this is the argument that you were making, but I would not say that we need law for robots. We need law about robots, regulation that better suits the technical and technological aspects of artificial intelligence. We need regulation that is knowledgeable about all those debates we've been having for the past 2 days, but we don't need to make law for robots. I don't see robots as things that deserve law the same way that and it kind of makes me think about the way that we talk also sometimes in law and robotics about we can give rights to robots because we give rights to rivers, we give rights to animals. We don't give rights to animals. We give rights to the people that are surrounding the animals, better constraining their behavior, giving the power to claim, to go in front of the court to people around the animals and the rivers, to better constrain the behavior by other actors. But we're not giving rights to rivers or animals. Those are legal fictions, and I would rather we didn't go through the process of creating a new legal fiction with robots. Thank you, Nikita, for your comment. I think it is definitely very relevant. I tend to shape things in a very Manichaean way, so this is definitely something I will think about. About speed limits, it's totally out of topic, but actually most of our cars' sensors do not tell us the exact speed at which we're traveling. They systematically make it 5 kilometers per hour more quick. So that in effect, when we're at 80 kilometers per hour, we're at 75. So if you're at 85 kilometers per hour and the speed limit is 80, actually you are following the rule, but that's probably not answering your comment about AI. Thank you very much, Bert, for this, and I'll definitely get in touch with him to ask about this literature.
Wow, thank you, Leonard. You managed all the questions. That's impressive. And what a panel. Thank you so much. Such a roller coaster through topics. Thank you to all the presenters, and thank you for the very engaged audience / participants. I now rest my case as a moderator and hand over to Giovanni and Giuseppe to wrap up the conference. Thank you so much.
Managing so well the last part of our conference when everybody is very tired but still lively. Giuseppe, do you want to say a few couple
yes,
words?
we are all tired, so I just to thanks again you, Giovanni, Ryan, and the university, and then my hope is that we can have a follow-up, because I think that it was extremely interesting 2 days, so we can have perhaps a follow-up with another event the next year, or perhaps to start a publication or something that could be a new idea. My proposal is the follow-up, and then I promise that I will violate any GDPR rule, because I will invade your email with a lot of spamming, and then we can keep in contact with this kind of initiative. Okay.
You want to say a couple of words?
Yeah, I mean, thank you to those of you who stuck this whole thing out and are here on a Saturday evening almost. Thank you very much. Thanks so much to the organizers who did a tremendous amount of work, and your staff has been incredibly professional and helpful, and everything's gone really wonderfully from my perspective. And I hope that this is just the beginning, and that we keep in touch and do this again.
Yeah.
Yeah.
So okay, so thanks everybody. I would like just to say a couple of words again for our generous supporter, that is Google on the one hand and the Tech Policy Lab on the other hand, who have enabled us to organize this event. And then I would like also to thank the co-organizer, that is Francesca Bosco, who's not here with us. She's in Kenya, maybe she's already there for a work work commitment, and Ryan and Giuseppe. And also I would like to thank Francesca, who also helped us in organizing this event, and Ula and Laurence, who are not here but were essential in getting us together. So thank you everybody. Enjoy Florence and the sun, which is outside.